This video aims to review some big ideas in coordinate geometry in preparation for an investigation that's being held in term 2. Okay, so the big ideas we're looking at are the number line, the number plane, plotting points, substitution and linear relationships. So let's start out with the number line. Hopefully you're very familiar with the number line. We've got 0. Usually we put 0 in the middle, and then we stretch to the right as far as we really want to go in a positive direction, or we go in a negative direction to the left. And normally you grab out your ruler or use a grid and say that might be 1, 2, 3, 4, 5 off into infinity. And these of course would be -1, -2, -3 off into infinity that way as well. If we wanted to use a number line, we could say, let's imagine x was 4. Then we just look along and say, there's x, because x is 4. Now look, that idea will become clearer once we start adding it to other things. So let's move on. Here we have the number line again. You can see it hiding in there. And of course, the number line we're going to call x. All the x values will go along the number line, but we're going to add another line to turn into a number plane. Here we have what's known as the x-axis going left and right, and the y-axis. Together, the x and y-axis make the number plane. Now hopefully you remember this from 7, 8 and 9. What we're going to do is we're going to plot some points onto the number plane. And we need both left and right and up and down. We need x and y to plot points. And luckily, they always come in the order that we learnt them. The x value, the left and right, will always come before the y value. Now some of you may want to pause the video here to practice these example ones we've got here, and then I'll do them as well. So you can either pause it now or watch a couple and pause it and try some yourself. Okay, we're going to start with A. Point A always comes in the form x before y, so the x value is 3, it's positive, so we're going to go left and right. We're going to go right by 3. 1, 2, 3, and then our y value is 5, positive 5, which means we go up 1, 2, 3, 4, 5. We draw our point, and that point is A. Notice how I draw the point and then label it. Let's try B. -2, which means go left by 2, and then positive 1, up by 1. Left by 2, up by 1, and that's our point B. Here's C. C is interesting because it says 0. Don't go left, don't go right. Just go up by 8. So don't go left, don't go right. Just go 1, 2, 3, 4, 5, 6, 7, 8. 8 up, and that's the point C. Let's keep going. D is 3 in a positive direction, so 3 to the right, and then down by 2. 3 to the right. 1, 2, 3, and down by 2. There's our point D. And our last point, E, 5 to the right and 7 up. Notice how it always is left and right and then up and down. So right by 5. 1, 2, 3, 4, 5. And then up by 7. 1, 2, 3, 4, 5, 6, 7. Right. Okay, good so far. That's E. Okay, so what have we looked at so far? We've looked at the number line, the number plane, and plotting points. Now we get to substitution and linear relationships. Look, this here, this thing up here, is a linear relationship. I can tell because it's got x and y together making another number. Now, how do we use that? This is not just one point. This is actually an infinite number of points. What we're going to do is we're going to use substitution to make some of the infinite number of points that make up this linear relationship. So substitution is really just the act of taking a letter out and replacing it with a number. Now I could replace it with any number I want, so I'm going to choose a simple one to begin with, and I'm going to say x equals 2. So what I'm going to do is rewrite this number relationship out, this linear relationship, but I'm going to replace x with a 2. So 2 plus y equals 5. Now I've made an equation. I've made an equation that I can solve very simply by just saying minus 2 and minus 2. I do the same to both sides to be fair. You'll notice this 2 and this minus 2 will kill each other off, leaving y equals 5 minus 2 is 3. So what we've done here, we've said when x equals 2, now remember from plotting points, when x equals 2, y equals 3. We've made a point using this linear relationship, the point 2, 3. So I'm going to plot that, 1, 2, 1, 2, 3. There's our first point. Doesn't look like a line yet, so let's find another point. This time we're going to make x equal 4. So I'll rewrite my linear relationship, 4 plus y equals 5. Now I'm going to solve this equation because now it's turned into an equation. Minus 4 from both sides, that will kill that off. Plus 4 and minus 4 will kill each other off. Y equals 1. So this time when we decided, nobody told us, when we decided that x was 4, y ended up being 1. So let's try plotting that point. 4, 1, 1, 2, 3, 4, 1. Now some of you may see we're starting to see a line emerge. Our linear relationship is starting to emerge. Let's just do one more point. Generally, I encourage people to do at least 3 points to really see that linear relationship occurring. We don't have to do it in any particular order. We can decide what to replace in for x, and we will get a value out for y. So this time I'm going to make x equal 1. Let's see what happens there. So I write it out. 1 plus y equals 5. And again, I'm just going to minus 1 from both sides. That will kill that off. Y equals 4. So this time when x was 1, y was 4. We've got that point 1, 4, 1, 1, 2, 3, 4. You'll notice that's in a line. I could keep doing this all day. Well, I could. It wouldn't necessarily be very interesting for very long. But there's our line. And you can see I could find a point here. 1, 2, 3, 4, 5, 6. 6 minus 1 would be a point in this relationship. Let's have a think about it. 6 minus 1 equals 5. I could put any value for x in and find a point along this line. That's basically how we can use substitution to reveal a linear relationship as a line on a graph, as a line on a number plane. Let's have a look at one more. This time, instead of replacing x, I'm going to replace the y. It works in much the same way. Let's choose a simple one like 3. So we're going to rewrite this out. This time we know that y is 3, but we don't know what x is. Let's try it. X plus 3 equals 9. So this time I know what y is. I don't know what x is yet. So I'm going to minus 3 from both sides. That kills that off. X equals 6. There's our first point, 6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Is that right? 6 across, 3 up. Seems right. Let's try another one. Let's try when y equals 5. Okay. So we're going to do when y equals 5. We want to find out what x is, so we'll rewrite out the number, the linear relationship. X plus 5 equals 9. Minus 5 from both sides. X equals 4. And we have the point 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And again, we can see that line starting to emerge. Let's do one more point. But actually, I'm going to do one of the easiest points, if not the easiest point we can possibly decide on, and that's by replacing the y with a 0. Have a look at what happens when we replace y with a 0. When I substitute, when I say off you go y, and on comes the 0, x plus nothing is 9. I don't even have to do anything. That just disappears. X equals 9. We get the point 90. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't stress how lovely a trick this is to use. Let's try this time. Let's make the x the 0. And this time if we make x 0, we write it out again, but I'll replace the x with the 0 this time. So 0 plus y equals 9. Again, we can see that this just drops off. We don't have to do any calculation. Y equals 9. This time we have the point 0.9. So don't go left and right, just go up by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can see that line, no matter what point we chose, no matter what coordinate, what x value or what y value we chose, when we got that letter by itself at the end, when we got our point finalized, it's going to be a point on this linear relationship, this line type relationship. Oopsie. Let's try that trick again. So how can we tell it's a linear relationship? Because we have x and y equaling something. Some value for x, some value for y together equaling some number. And will generally produce a straight line. I'm going to have a look at one tricky one. This one tricky one requires that you are persistent, because you're not necessarily going to get nice, neat answers straight away. Now, let's point out what's hiding between the pronumeral and the coefficient. What's hiding between the letter and the number? There's a times in there. We've got a hidden times by in there. We just got to remember that when we do our calculations. So, I want to find out this time what happens when I put a 2 in for x. I'm going to replace x with a 2. Let's write it out. 2 lots of 2 plus 3 lots of y equals 12. Now this is a harder equation. It's going to take a little bit of mucking around. 2 times 2 is 4 plus 3 lots of y equals 12. I'm going to minus 4 from both sides. That kills that off. 3 lots of y equals 8. Now, because there's a times by hiding in between those two, this is 3 times bigger than it needs to be, so I need to shrink it down by using divide. I shrink it down. And I'll be fair and I shrink both sides down. The 3 divided by 3 kills itself off. I'm left with y equals 8 divided by 3. Now that is actually a true answer. Y is 8 divided by 3, but it doesn't divide in evenly. Some people might call that 2 and 2/3, and that's also true. But look, it's not what we're after. In this case, even though this is correct, this is a point 2 and 2 2/3. I really want to get whole number answers, and this is exactly why I say you have to be persistent. This 2 didn't work, so I'm going to try something else. This time I'm going to say, let's try making x equal 3. So I want 3 something. Now, there's no guarantee this is going to work. I just need to try it. So 2 times 3 plus 3 lots of y equals 12. 2 times 3 is 6 plus 3y equals 12. I minus 6 from both sides. Minus 6, minus 6. That kills that off. 3y equals 6. Now watch what happens when I divide both sides by 3. That kills that off. Y equals 2. This time I've got a nice whole number answer. Y equals 2. Now this is one point made up of integers, whole numbers. that I can put up here. 1, 2, 3, 1, 2. If I kept going and tried other numbers, eventually I would reveal this linear relationship. Now, unfortunately, I cannot keep going because I don't want to compromise the integrity of the assessment task we've got coming up. But I would encourage you to review these skills and make sure that these are familiar to you before you start on the investigation. Thank you for your attention.